Okay, today we're going to look at section 2.6, transformations of graph. Excuse me. We'll start with vertical translations. So what we're doing here is moving it left and right vertically. So if we consider a function defined by y equals f of x, and we let k represent a positive real number, the graph of y equals f of x plus k is the graph of y equals f of x shifted k units upwards, and the graph of y equals f of x minus k is the graph of y equals f of x shifted k units downwards. So let's look at this. Well, let's start with use translation to graph the given function. Now let's look at g of x equals the square root of x minus 2. So we have, we'll let f of x equal the square root of x. So we're looking at f of x minus k, which in this case is 2. So we're moving it downward. So first, let's look at this graph of the square root of x. So if x is 0, we have 0, 1, 1. And if x is 4, we have 2. And we're looking at a shape something like this. Now we want to move that down 2. So go down 2 here, down 2 here, and down 2 here. And that is it. So this was f of x, and this is g of x. Let's look at another one here where we add. So let's say h of x is equal to the square root of x plus 3. That means that f of x is simply the square root of x. We're adding, so we're shifting up. So same deal. Start with our square root function. And now we're going to move it up 3. 1, 2, 3. So this is f of x, and this is g of x. Simple, right? Next, we have horizontal translations on graph. So again, we'll consider a function defined by y equals f of x. We'll let h represent a positive real number. So here's a typo here. This should be h and h. The graph of y equals f of x minus h is the graph of y equals f of x shifted h units to the right. This will get a little tricky. Minus is to the right, and the graph of y equals f of x plus h is the graph of y equals f of x shifted h units to the left. Plus is left. Seems counterintuitive. So let's look at an example of this. And let's see, we have q of x equals the square root of x plus 2 minus 5. So we went all out on this one. So We start with, we have an f of x as simply the square root of x. Then we have a g of x. That's going to be the square root of x plus 2. And we're going to add an h of x here. Well, our q of x actually would be the next one. So let's start with our square root function. Again here, we have plus h, or plus 2. So we're going to go 2 units to the left. And we're going to do that. Then we're going to subtract 5, which means going down 5 units. And this is our q of x here. So let's look at some graphs. Let's start with f of x equals x squared. That's a fairly simple one. X is 0, f of x is 0, 1 and 1, negative 1 and 1, 2 and 2, 3, 4, negative 2 and 4, and we end up with a shape called a parabola. And this is curved down here. Okay, now let's look at g of x equals 3x squared. So again, when x is 0, we have 0. When x is 1, 1 squared is 1, but we have 3. And negative 1, we have 3 as well. And what's happening here is it's the same general shape, but it's kind of gushed in. So let's look at h of x equals 1/3 of x squared. Okay, so let's look at this one. Again, 0, 0. Now when x is 1, y is 1/3, and negative 1, 1/3. When x is 2, we have x squared is 4, so we get 4/3, which is a little over 1. And we're going to get negative. And you see what's happening here. Again, the same general shape, but we're stretching it out. Which brings us to our next thing here. Vertical shrinking and stretching of graphs. Consider a function defined by y equals f of x. Let a represent a positive real number. If a is greater than 1, then the graph of a times f of x is the graph of y equals f of x stretched vertically by a factor of a. If 0 is less than a, which is less than 1, then the graph of y equals a times f of x is the graph of y equals f of x shrunk vertically by a factor of a. Note, for any point xy on the graph of y equals f of x, the point xay is on the graph of y equals a times f of x. So the reality is we just did these. See, we had the point 1, 1 here. We had the point 1, 3 here. 3 times a, or 3 times y. And here we had 1, 1/3. So this is vertical shrinking and stretching. Okay, so we'll just use those for that above. Okay, now let's talk about horizontal shrinking and stretching. Consider shrinking and stretching, horizontal shrinking and stretching of graphs. Consider a function defined by y equals f of x let A represent a positive real number. If A is greater than 1, then the graph of y equals f of A times x is the graph of y equals f of x shrunk horizontally by a factor of 1 over A. So again, this is the reverse of what we did with vertical. If 0 is less than A is less than 1, then the graph of y equals f of A times x is the graph of y equals f of x stretched horizontally by a factor of A. Nope, of 1 over A. And we note for any point x, y on the graph of y equals f of x, the point x divided by a, y is on the graph. So here we're changing the x by dividing it by a. Here we change the y by multiplying it by a. So let's see if we have some examples of this. So let's look at well, they give us this. They give us a graph. And we have 2 points on it. We have this point here, or 3 points, 0, 1. And we have a point down here, -2, -3. And we have a point up here, 3, -4. Or -3, 4. So this is our original graph. F of x is in red. So let's change colors here. And we'll go y equals f of 2x. Now let's look at what this says. So a is 2. A is greater than 1. So this is saying that our x coordinates will be 1 divided by a. So we'll divide our x coordinates by 2 and leave the y coordinates the same. So 0 divided by 2, this point stays. -2 divided by 2 is -1, so we have -1, -3. Oops. I did that backward. No, I did that. Yeah, I did that backwards. All right. Put this back. So now instead of -2 to -3, we have -1, -3. Now instead of -3, 4, we have -3/2, 4. And so that is my new one. See how we vertically squeezed it? Or we horizontally stretched it, one or the other. Kind of looks the same. Okay, so now let's get us another color here. And we're going to have y equals f of 1/2 x. So this basically means our y values are going to stay the same, and our x values, we're going to divide them by a, so essentially we're going to double them. So this becomes -6, 4. This becomes -4, 3, and this still becomes 0, 1. And so you see how we stretched it horizontally. We stretched it out here. We squeezed it in here. So what about reflections across the x and y axes? Consider a function defined by y equals f of x. The graph of y equals negative f of x is the graph of y reflected across the x-axis. Because negative y becomes positive y and positive y becomes negative y. The graph of y equals f of negative x is the graph of y equals f of x reflected across the y-axis. So let's look at an example of this. Again, we're just going to go with a graph. Now I have a point here at -1, 0. And I have a point up here at 3, 3. And I have a point down here at 4, 1. And that's my initial f of x. So now let's look at y equals negative f of x. So what happens here? It's reflected across the x-axis. So that means instead of 4, -1, or 4, 1, I have 4, -1, right? Flip it. If I fold across the x-axis, these 2 points would touch. Here I have 3, -3. And here my y would be the same. Now, can you see how that would flip? If I folded it here, this would come here and they would touch. It would be the same thing. It's a reflection. Now, what about y equals f of negative x? Now, this means I'm reflecting across the y-axis. So now my y values or my x values change because I'm flipping across here. So this becomes -4, 1. This becomes -3, 3. And this becomes 1, 0. And again, you can see if I flipped it here, they would intersect. Okay, so this is all well and good, but chances are I'm going to have something that looks relatively nasty. So we have an order of operations for translations and reflections, and it goes something like this. To graph a function requiring multiple transformations, use the following order. First, we do the horizontal translation. Then we do the horizontal and vertical stretch and shrink. Then we reflect. Then we do vertical translation. So let's start with one. And let's keep it moderately simple. How about m of x equals -3 times the absolute value of x minus 2 minus 4. Now, me personally, I like to follow this step by step. So my original equation, and let's just pick a, better not be that one. My original f, that's too close. No, not. F of x would simply be absolute value of x. Okay? So the absolute value of x, if you were not aware, is simply this. We have the point 1, 1, 2, 2, negative 1, 1, negative 2, 2. Those are those points. Now, first thing I need to do is horizontal translation. Okay, horizontal translation. So that means this here. So next up, I'm looking at f of x equals the absolute, or we'll call it g of x now, absolute value of x minus 2. That's our horizontal translation. When we subtract, we shift right 2 units. So that means 1, 2, like that, and like that. Okay, next we have horizontal and vertical stretch. Horizontal and vertical stretch. That's how we multiplying by anything inside. We are not. So there is no horizontal. So next we look at vertical. Okay, vertical, we have a 3 here. So again, so now h of x, don't worry about the negative. That's a reflection. We're going to do that next. Now we have 3 times x minus 2, absolute value of x times minus 2. So if it's a is 3, a is greater than 1, it's vertical stretch. So x stays the same, y is a times x. So now I have this is the same, this, and then instead of 1, it's 3. Same here. And this is going to go like this. We're stretching it vertically. Kind of looks the same as shrinking it horizontally, but it's not. Or not necessarily. Next up, on our list is reflection. I do j of k, negative 3, x minus 2. So we're taking the negative of f of x. That is reflection across the x-axis. So I'm simply going this route, taking this one here and reflecting it across the x-axis. And then lastly, I'm subtracting 4, which is vertical translation. And subtracting means to shift downward. So 1, 2, 3, 4. And we can go back to our original red now. And there we go. So that's how this works. It gets a little messy, a little confusing at times, but it can make things easier. And I will tell you there are questions like this on the exam. I'm not sure how many offhand. I'd have to look at the study guide. But that's all for this one. Everybody have a good day, and I will see you next time.